The first thing you want to do, if you haven't done so already, is to just get to the GitHub page. So I'm going to open up a browser and I'm going to type www.github.com/LDOBrian1234/transinfo. This will bring us to the GitHub page, and here we want to download the code. The simplest way that I know how to do that is to click this big green button here and then click download zip. And this may take about a minute, so we'll just wait for that to download. It seems to have downloaded. So let's open up our files, go to downloads, and yeah, we see that there's this transinfo main file, which should contain the same files as the GitHub repository. We can move this file wherever we'd like. I'll move it to the Documents tab over here. And then the next thing we want to do is to open up this folder. And one thing you'll notice is that there's several subfolders within this folder. But all the folders here are actually giving us data from the example in the GitHub repository. And we don't want this data to get mixed up with our own data, so we're just going to go ahead and delete these folders. So I'll highlight them all and click Move to Trash. Now we want to move our image folder into the transinfo folder. For me, my images are contained in the folder angiosperms, so I'm going to go ahead and move that into transinfo main. And this can also contain subfolders which have images. So we have these subfolders: early angiosperms with images, asterids with images, etc. And this is going to help our algorithm group the data and compare the data accordingly. Make sure you have MATLAB installed. Once you have it installed, you want to open up userinput.m. And this may take a minute, but it should open with MATLAB. Once it opens, all you need to do is click Run, and then it's going to prompt you to input the name of your image folder. So for us, the name of the image folder is angiosperms. I'll just type angiosperms here, click Enter, and then the code should run. And this may actually take several hours, so just be patient and we'll come back and show what the output should look like. Once the code is run, let's go back to our original folder. So I'll open Finder, go to Documents, and then transinfo main. Now if I open this, there's many more subfolders that we didn't have previously. And we're going to be able to get the most information from plots, PCA plots, all PCA plots, and GW tau plots. So I'll go through what's contained in each of these folders next. In the plots folder, the first thing you'll notice is that the structure follows the same structure as the original image folder. And for each image in the original folder, we have a corresponding image in the plots folder. If I open one up, you'll see that we have the original image on the top left, and on the top right, we've also found the rotational center of the image in red and the reflectional center given in cyan. Then we also compute the TI by rotation and reflection for both the rotational center on the top and the reflectional center on the bottom. So a total of 4 TI curves for each image. PCA plots is also organized like the original image folder. And if I open it up and go to a bottom folder, what we've done is we've taken all the images in the bottom folder and compared their TI curves using a principal component analysis. We do the principal component analysis and plot the first 2 principal components. Since we have 4 TI curves, this gives us 4 different plots. And if I open one up, you can see that some of the flowers have more similar symmetries, while there's some outliers with some different symmetries. In PCA plots, we are comparing the symmetry of images within a class. In all PCA plots, we're comparing the symmetry of all the images. This gives us 4 plots, 1 for each TI curve. And if I open one, you'll see that the data points are also color-coded based on the class that they're in. In our application, we're seeing a lot of overlap between the colors, so this provides evidence that there's some convergent evolution of the symmetries. This is a very useful tool to compare the symmetries between different classes. In GW tau plots, we consider another method for comparing the TI curves. We use a tool called GW tau, which can give us distance between the curves. For each of the 4 TI curves, we compute a distance matrix, and this gives us the distance between every TI curve. Then, given this distance matrix, we can embed the points into 2-dimensional space using multi-dimensional scaling. And again, we color code the data points based on the classes. Just as with the PCA, we can see that there's lots of overlap between the classes, indicating that there's some convergent evolution of symmetry in our application. This is another method to compare the difference between symmetries in different classes.